mole is a concept that allows chemists to count atoms and other numbers that are really, really big. When you hear the mole, you might be thinking of a small burrowing animal or perhaps a secret agent. However, a mole in chemistry is a very important term, and it's going to help you to be very successful in your class. Now, when we think of a mole, it is a very specific number of 6.02 times 10 to the 23rd. Kind of like if you hear a dozen pencils. A dozen pencils is always 12 pencils. A dozen cars will always be 12. 2 dozen apples will always be 24 apples. And 6 dozen birds will always be 72 birds. So a mole is a counting unit. It is often abbreviated MOL, and it's a unit in chemistry that allows us to deal with numbers of atoms, molecules, ions, or even formula units of the same substance. Chemists have defined a mole as the number of carbon atoms that are exactly 12 of pure carbon 12. So just like a dozen is equal to 12 of something, and a pair is always equal to 2 of something, chemists have established that a mole is always equal to 6.02 times 10 to the 23rd of something. In chemistry, that something could be atoms, molecules, ions, or formula units. So just like the number in math class, 3.14159 has a name called pi, 6.02 times 10 to the 23rd in chemistry is called Avogadro's number. Now, would you say a dozen pencils weighs the same as a dozen cars? Of course not. While the amount of the objects is the same, we would expect the mass of them to be very different. A mole of anything representing the same amount of particles, but it does not represent the same mass. So the amount is the same, but the mass is very different. There is a link between the mole of particles and grams. The mass of 1 mole is always equal to the molar mass of a substance. So let's take a couple minutes to complete this chart. 1 mole of oxygen will be 6.02 times 10 to the 23rd. The mass of oxygen, according to your periodic table, is 16 grams. 1 mole of a substance of bromine is 6.02 times 10 to the 23rd, while the mass of bromine on the periodic table is 79.90. 1 mole of gold is 6.02 times 10 to the 23rd, while the mass of gold on your periodic table is 196.97 grams. 1 mole of water is 6.02 times 10 to the 23rd, while the mass of water is 2 hydrogens plus 1 oxygen, all from the periodic table, will be 18.02 grams. Now, 1 mole of sodium carbonate is 6.02 times 10 to the 23rd, while the mass of sodium carbonate will equal 2 sodiums, 1 carbon, and 3 oxygens. So if you add those up, you get 105.99 grams. Let's do some practice with converting grams to moles and moles to grams. All right, we're going to do some practice for grams to moles and moles to grams. You need a calculator, something to write with, and a periodic table. The first one we're going to do starts with 0.3 moles of sulfur, and we're solving for weight. Weight is always in grams. So just a reminder, you start with your given. So 0.3 moles of sulfur. If you have moles of sulfur at the top, you need moles of sulfur at the bottom. Okay? You can put the 1 in here if you want to. You don't have to. 1 mole of sulfur is equal to the formula weight. So if you look at your periodic table, the formula weight of sulfur is 32.06 grams. We cross out our moles, and then we're going to solve. You multiply the top and divide by the bottom. So 0.3 times 32.06 is 9.618 grams of sulfur. Take a minute, check in with your teacher if you have any questions, but make sure you did it like mine. Let's do a second problem. Our question says, what is the weight of 5.5 moles of silicon? So our given is 5.5 moles of silicon. If you have moles of silicon at the top, you need moles of silicon at the bottom. Our units are always the same at the diagonal. 1 mole is equal to the mass of silicon. The mass of silicon is coming from the periodic table, which is 28.09. Okay. Our moles cancel out, so then you're going to multiply. 5.5 times 28.09 is equal to 154.49 grams of silicon. Does your answer match mine? Take a few seconds to solve the problem. All right, number 3. We're going to flip it and go the opposite direction. This time it says how many moles are there in 45 grams. So my given this time is 45 grams of water. If I have grams of water at the top, I need grams of water at the bottom. Now, since it's more than one element, you do need to find the formula weight. We have H and O. We have 2 hydrogens and 1 oxygen. The mass of hydrogen is 1.01 on the periodic table. The mass of oxygen is 16 on the periodic table. So 2.02 plus 16 is 18.02 grams. And the formula weight is equal to 1 mole. So you're going to multiply the top. 45 times 1 is 45, divided by 18.02, and we get 2.49 moles. Okay. Take a minute to solve and see if your answer matches mine. We have a few more we're going to do. Our 4th problem is change 34 grams of CCl4 to moles. We start with our given, 34 grams of CCl4. If I have grams at the top, I need grams at the bottom. We get our grams from the periodic table. We have C and Cl. There's 1 carbon. There's 4 chlorines. The mass of carbon on the periodic table is 12.01. The mass of chlorine is 35.45. So 4 times 35.45 is 141.8. Plus the 12.01 is equal to 153.81. We can plug that in. And that is equal to 1 mole because the formula weight is always equal to 1 mole. So now we can solve 34 times 1 divided by 153.81, and we get 0.22 moles of CCl4. Take a minute to see if yours matches mine, and we're going to do one more problem together. Number 5 says, what is the weight of 4.3 moles of sodium? So we're solving for grams. We're starting with moles. So 4.3 moles of sodium. If I have moles at the top, I know I need moles at the bottom, so that's 1 mole. And then the grams of sodium is going to go at the top, which is 22.99. So 4.3 divided by 22.99 is equal to 0.19 grams of sodium. Take a few minutes to see if yours matches mine. If you still have questions converting grams to moles and moles to gram, please check in with your teacher.